Hello, welcome to my video on topological sort. Today, we will discuss a graph theory algorithm that allows us to sort a directed acyclic graph in linear order, which means if there is an edge from u to v in graph, then you will always come before v in linear order. Let's start by understanding what a DAG is. A DAG is a directed graph with no cycles, which means it's a graph where it's impossible to start at one node and follow a path of edges that leads back to the same node. Here we have a directed graph with 5 nodes A, B, C, D, and E. From A we can go B and C, from B we can go D, from C we can go D, and from D we can go E. So, if we convert this graph in linear order, we will have two possible solutions A, B, C, D, E and A, C, B, D, E. As B and C do not depend on each other, we can pick them in any order. So now that we understand what a DAG and topological sort is, let's see how we can use it in real world. This algorithm can be used to stabilize the sequence of events that are interdependent, such that task scheduling. For example, to catch a flight, one must first reach the airport, then pass through security, and finally board the flight. Therefore, we can say that the task of passing through security is dependent on reaching the airport, and boarding the flight is dependent on passing through security. Now, we will look into the process of converting DAG into linear order. First, we will calculate the in-degree of all the nodes. Do you know what is in-degree? In-degree of a node is count of edges which are coming on that node. As you can see in graph, A has 0 in-degree because no edge is coming to A. We can say A as a source node also. B and C has in-degree 1, D has in-degree 2, and E has in-degree 1, which means C depends on two nodes and all other nodes depend on only one node except A, who does not depends on any. Now let's look into the algorithm. First, calculate in-degree of all the nodes. Now, start with any node with 0 in-degree, print it, and then traverse all its neighbors and decrease their in-degree by 1. If in-degree of any node becomes 0, then add it to the list to be traversed and repeat the steps 2 to 5 until we visit all the nodes. Let's visualize it. So here we have a graph. So A has 0 in-degree. We will pick that node and decrease in-degree of its neighbor by 1. Now B and C has in-degree 0. We can pick any from B and C. So let's pick B. Now as we removed B, in-degree of D will be removed by 1. So in-degree of D is 1 and in our answer list we have A and B. Now pick C. So we have picked C and decrease the in-degree of D by 1. So now D has in-degree 0, we can pick D, and now E has in-degree 0, so we will pick E, and our answer will be A, B, C, D and E. Similarly, if we have picked C before B, our answer would have A, C, B, D and E. Runtime complexity. Let's visit the algorithm again. If we clearly look into the algorithm, we will find that we are visiting each node and each edge only one time. So, by this analysis, we can say that runtime complexity of this algorithm will be O of V plus E. Now here I have coded a solution. You can look into it and understand. It's pretty clear that first we are calculating the in-degree and then we are making an adjacent graph and maintaining a list of visited nodes. Now for each edge we are building adjacent mapping and in-degree. Now we have created an available list of nodes where we are picking nodes which have are 0 which have 0 in-degree, and we will traverse that available list. We will pop a node from front, mark at visited, and append it to the answer. And now we will visit all its neighbor. And if that neighbor is not visited yet, we will decrease that in degree by 1. And if in degree becomes 0, we will put that node into that available list, and we will repeat that process. We will try to solve it using an lead code problem called course schedule. Let's look into the problem. There are a total of number of courses you have to take labeled from 0 to n minus 1. You are given an array of prerequisite where we can say a course AI is depends on course BI, which means before completing AI we need to complete BI. So now we have number of course, we have in degree of each course 0, we have adjacent list of each node as empty, and we have not visited any node, so we can say visited will be false. Now we will visit each prerequisite and build adjacent list and in degree. Now that we are building an available list where we are picking the nodes which has 0 in degree, and we will traverse through available list. We will pick a node, mark that visited, and append it to the answer. Now we will visit all its neighbor, and if that node is not visited, we will decrease the in degree and check if in degree becomes 0, move that to the available list. Now see what would be the answer. So we are running it over a test case, and let's wait. Voila, it's passed. So we will check it on another case, and great. We are we are able to pass all the test case. That means we are good. Thank you for joining me. Let's meet again for some other tutorial video. Thank you.